Thanks everyone for joining this webinar and good evening first of all. It's already 5:10 in the evening, so yeah, I hope I don't bore you with this talk. You find a lot of interesting things out of this and probably something that you can take back to your work tomorrow or in the coming time. And probably this helps in some of your projects that you are currently working on. So before I start, a brief introduction about myself and Prashant. So we come from uh, the application engineering group inside MathWorks. Our group is primarily dedicated to working with the customers. So we are kind of the front-end force inside MathWorks that works with the customers directly. So anytime you have kind of technical issues or like things like where you want to know more about our products, try out some of our products, we would be the people whom you would be getting in touch with, and we would be helping you in using some of these tools, developing some of the solutions using our tools, and basically giving you the best, making sure that you get the best out of the tools that you want to use. And again, in that particular group of ours, myself and Prashant, we both work in the areas of production code generation, model, and code verification. So with that, let me just get started with this webinar that is there. And the primary discussion that I'm going to have is about like how can model-based design be used in general for developing ISO 26262 softwares, and how can it also be used to improve your software quality and meet certification standard, and what's the general workflow, and how does MathWorks help in that achieving that workflow, especially from an ISO 26262 point of view. So before I go into the workflow,
Rajat, you're not audible right
maturing,
now. Yeah, now good. Yeah.
is it fine? Yeah, I have a kind of a weak internet connection at this point of time, so let me know if I'm audible fine.
Yeah, sure. Yeah, now it looks good. Continue, please.
Okay, okay. So yeah, like I was saying, so one of the biggest challenge that we're seeing that our technologies around us, they are maturing and coming up at an exponential speed, and at the same time, we have to meet a lot of standards that are cutting across our industries. So whether it be ISO 26262 in automotive, whether it be DO 178C in aero, and there are other standards for other industries also. And all of these projects, especially which are safety critical, these projects tend to be more costly over a period of time because they not just involve the regular process of developing the software or the final product that you're developing, but they also involve in developing or making sure that the product that you're developing, whether it be software, hardware, or a combination of both, it is also safety relevant and handles all the safety critical use cases that your system might encounter. So that makes our projects more critical, and we need to make sure that they are defect free at the same time. And we have over a period of time also seen this, and there is a NASA study also on the same, that uh, the moment you find defects later, the later you find defects in your process, the cost of fixing them also increases. So the best approach that could be there is that we are able to find these defects as early as in our development process. And the best way could be like as soon as we start working with our requirements and we have some sort of executable specifications or executable prototypes, we should be able to test out our requirements before we even go on to the implementation phase of these requirements. So that's how the whole idea of model-based design also developed. Basically, model-based design as an idea promotes early testing, early verification of the systems or the requirements that we are developing. And also, at the same time, now recently also, ISO also recognized that Simulink and Stateflow, which basically are the platform products for developing models inside MATLAB, they are basically suitable tools where you can design and create your logics. So as you can see, I have this excerpt from the ISO 26262 document, which basically says that Simulink can be used in case of Simulink, and Stateflow can be used as a modeling environment. So even now, the ISO does recognize that these tools can be used for doing model-based design. So how then we can proceed when it comes to ISO 26262, and where does Simulink and model-based design apply basically when it comes to ISO 26262? So as we all know, in terms of ISO 26262, the entire standard is divided into 12 chapters. And mostly the most relevant chapters, as you can see in front of you, are chapter 4, 5, 6, 8, 11 from a model-based design point of view. And primarily, chapters like chapter 6 are the most important and the most relevant chapters from a model-based environment point of view. And that's what I'm going to cover as part of today's talk also as I move on. But along with that, another chapter which is or another area which is of utmost important, both from an ISO point of view and also as from a tool vendor point of view, is how do we support you in the entire process of developing a product or a software that is compliant to ISO 26262. And that is basically by providing you all the relevant artifacts and relevant documentation required so that the tools that you use from MathWorks end can be easily qualified for your particular projects that you are developing following the ISO 26262 standard. So that is another part that I would be also talking about, which is basically the tool classification and qualification part later on. So let's first have a quickly kind of a deep dive into the ISO 26262 chapter 6 coverage that we have. So we all know that the ISO documents, especially the chapter 6, is full of these tables which specify how you are supposed to go ahead with your process of software development, whether it be at the unit level, whether it be at the architecture level, whether it be at the implementation step, or whether it be at the testing step. So all these details are provided by ISO in the form of these tables, and these tables are also partitioned according to the ASIL levels. So not all components would be at the same ASIL levels. The lowest would be at A, and the highest or the most criticals would be at D level. And as you can see, there are about 15 or so tables inside the chapter 6 document. And each of these tables have their own subsections into it, or you can say sub-guidelines into it. As you can see, one of the tables that I have over here is table 9, which talks about structural coverage metrics at software unit level verification, basically. And again, like if you see, this is just one of the tables. There are many such tables that are there in the ISO document. And from a model-based point of view, if you see, we support almost all the tables and all the requirements that are there as part of this chapter 6, especially the ASIL tables that I was just talking about, barring a few of them. Okay, so a few of them, as you can see, are not covered. And essentially, if we see, or if we go do a deep dive into these tables, we'll realize most of them are not relevant also from Simulink or from a software perspective that MathWorks is providing. So basically, one of the tables is table 2, and point number 1D in it, it talks about formal notations. Simulink is a semi-formal notation language, so it does not qualify this one. But again, this is not a hard-coded requirement, so it's a recommended. requirement. And then there are some other points that are there which require more of manual intervention, even from an ISO point of view. So for example, there is something called as pair programming, which requires some sort of manual intervention. And then there is error guessing that is required in table 8, 1D point. Again, this is something which requires manual intervention. There are a few other points or other tables and points in some of these other tables, which again do not fit into exactly software tools area, but can be done or can be achieved outside of the Mathworks tools environment, which is basically like using ECU network and the environment or the complete infrastructure to test some of these things, and also even doing a vehicle level testing. So these are few things where we do not play a role, but in most of the other cases, we have a clear-cut role to play, and we also support in most of these areas. Moving forward from here, not just ISO 26262, Mathworks and the products that run basically on top of MATLAB and Simulink, by using these products, we do support all the other standards that are there for different industries also. So apart from ISO 26262, there are other standards for other industries like DO178C, which is relevant for aero, and a lot of other standards. And for most of these standards, we do provide, along with for ISO, we do provide something called as a certification kit. Now, the certification kit, basically the IEC certification kit from an ISO perspective, will provide us with all the relevant artifacts required to qualify the tool and qualify the process that has been used via these tools to develop the software, or develop basically the entire software for the product that you're developing. So it has all those artifacts, so that at the end of the day, when you have used all the products as part of the workflow, you can run the artifacts. Okay, so there are use case test cases that can be executed, and finally you would get a report out of this, and this report can be submitted to the auditors so that you can get your tool also certified at the same time. Again, we understand it is hard to digest this straight away, that, okay, we have to do this. But to give you more confidence, we have also done a pre-qualification kind of a thing at our end also. So most of the tools that are used in the ISO 26262 process that you would be encountering, and I'll be talking about as I go ahead, have been pre-qualified already by TÜV for most of the ISO development AC levels. And I'll be talking about at what TCL level they are at a later point of time. Okay. And similarly, it is also relevant for DO qualification kit also, and the products that are used in the DO workflows also. Okay, now this was about ISO and how we support ISO by providing these cert kits and all. There are a lot of customers of ours who are already using these solutions. Some of you might be already aware of these customers. You might be you might be also using or encountering some of these products in your daily day. But here are two examples that I have. One is Coastal, which is a steering column supplier, and they developed an ASIL-D certified solution using Mathworks model-based design solution and products. And then on the other hand, there is Base Systems, which delivers DO178B level A flight software, level A flight software based on model-based design. And recently, LG Chem, which is a well-known battery management supplier, also was able to not just create, not just get a product, not just get its software ASIL-C certified, but that software was also complying to AUTOSAR. And again, for AUTOSAR development, they were also using Mathworks Embedded Coder or code generation solutions. And as you can see, I've highlighted one of the quotes from the article that is there on our public website, the link for which is also there. Once you get the slides, you should be able to access the link also. but I'll just read out this. So this is what they say in the article, that with model-based design, MATLAB and Simulink has enabled us to increase component reuse, reduce manual coding, improve communication with our customers, and deliver a high quality BMS. And the biggest benefit, if I just cut across this, the number of software issues identified in each software release dropped from about 22 to fewer than 9, well below our target for the project. So it's not just about meeting the ASIL standards and making sure that your software complies to a certain architecture, in this case like AUTOSAR, but it's also, at the end of the day, what's the bigger benefit that I get out of it. And in this case, as you can see, they were able to achieve component reuse, reduce manual coding efforts, and also the defects or the software issues went way below their expectations. So that was an added benefit for them. So using model-based design, again, you can also leverage all these benefits for your projects and get them done in a much better way and in a much shorter time with less money spent on these projects. So let's see how this process of model-based design that I have been talking about since we started basically work. So typically, in any standard workflow that we might be working on or we might encounter in our projects, we would typically start with textual requirements. And in a model-based environment, from these textual requirements, you would basically create something called as executable specifications. So from textual requirements, you would create something called as executable specifications, which are basically requirements that can be executed and validated. Okay, so that you know that, okay, whatever the requirements that have been defined can be implemented, and this is how they are supposed to work, by doing a prototype or a rapid simulation of those requirements in the form of models. Now, once you have got satisfactory results with those executable specification, you would add more details. For example, one of those details could be like your end controller might be a fixed point controller, or you might be using fixed point software development process. Okay, so in that case, you would use that same executable specification model, add fixed point details onto that, and add more finer software details onto that model, and prepare a model that's what we would call as the model that would be used for doing production code generation. Now, once this step is done, once you have reached this phase where you have this model, which is ready to be used for production code generation, the next of the step, which looks obvious, is basically code generation, but we won't actually jump onto code generation at this point of time. Okay, this is where now model-based design's actual benefit will come into the picture. We have created this model, and now we will start verifying this model and making sure that this model meets exactly what our textual requirements had asked us to do. And this can be done both at the unit as well as at the integration level also. And once you have done this, once you have analyzed that your model, which is now ready for code generation, is meeting all your requirements, you would also make sure that the model that you have prepared follows certain guidelines or follows certain best practices that are required for developing the models, and that are required to ensure that the code that gets generated is the best possible code that you can get, and also follows the guidelines. Now, once you have done this, you can move to the next step where you would generate the code. And again, the process doesn't stop there. The generated code will again then be back-checked with the model that you had developed earlier. And both the model and the generated code will be validated against each other using the same test cases that you had earlier used to validate your model. And if the generated code gives the same results as the model, then you can essentially say that your code generation process is a success. And at the same time, what you would be also doing is doing some sort of static code analysis and static verification on the generated code, which will basically ensure that your generated code is following the guidelines that are required. Okay. So this is in general typically a typical reference workflow that is used out and out in the industry or organizations which are using model-based design, and is also a reference workflow that TUVSUD has accepted for development of ISO 26262 softwares using model-based design. So let's have a deep dive into this workflow and see how each of these steps can be done inside model-based design or inside MATLAB and its related products. So let's look at the first side of things. So basically, which deals with model verification. Now, like I mentioned earlier, model verification would basically be okay. So I'll continue, sorry. So model verification basically, like I said earlier, encompasses 3 to 4 kinds of primary things that you would be doing. So these are basically managing the requirements, making sure that the design is working according to the requirements, measuring how much of your design has been tested, and making sure that the model that you're developing is basically what you can say is basically according to certain standards and does not misbehave in any scenario whatsoever. So this basically, like I said earlier, this basically forms the model verification part, and this is what we will start off with in this workflow. On the other side of the things is the code verification, which again deals with things like making sure that the generated code matches the model results, or both of them basically give exactly the same results. And again, you get full amount of coverage, basically making sure that entire code piece or the generated code is tested, and also making sure that the generated code is free from any defects. Okay, and it also follows guidelines like MISRA. And this basically forms the code verification side of things. So let's start with the first piece, which is managing the requirements. So basically inside Simulink, and primarily using Simulink requirements, you can ensure that all requirements are implemented. You can even go on and implement or create the requirements inside Simulink itself. So you no longer have to go to a third-party environment to author the requirements. You can author the requirements inside Simulink requirements itself. And at the same time, you can ensure that these requirements are linked with the models and the code and the test cases that you are later on going to create. So let's see how this process works. So like I said earlier, typically Simulink requirements would be your central tool, which will help you in working with requirements. And it can not only just help you in authoring requirements, but it can also work with external requirements that you might have already authored. So these external requirements could be in the form of doc, could be in the form of Excel files, or it could be also in the form of other third-party tools like DOORS, Polarian Integrity, and Teamcenter. So you can, again, work with these external requirements very easily along with Simulink requirement. And like I said earlier, you can basically link all these requirements via Simulink requirements back to your design, to your architectures, and to your test case, and even go on and link all these requirements automatically with the generated code too. And let's say if you have pulled in the requirements from some third-party environment, which is like a doc or an Excel or some of the third-party tools, and let's say you have updated them inside Simulink requirements or inside the Simulink's interface, and you want to take these updates back into your original tool that you might be using, then we provide a seamless mechanism to do this via the help of RecIF exchange format. This is a kind of a file format that is how should I say that? That is very popular amongst all the requirement management tools, and most of the requirement management tools do support this. Okay, so we can easily exchange the requirements between the two tools or your third-party tools and Simulink requirements via RecIF if that's the use case. And on the other side, if there are any mismatch of the requirements and the design, or if there are pieces in the design that are not linked, or if there are pieces in the test cases that are not linked with the requirements, you can easily again validate that and see why are they not linked, or if the requirements have moved, or if there was no requirement for that particular design piece or the test case. Okay, so I have a quick video demo to demonstrate how this entire requirement management piece works. So let me just start this video. Okay, I don't know, for some reason this is, oops. Okay. Okay, this is strange. Let me just see if it works. Okay, I don't know why this is not working. This is strange for me. Okay, sorry about that. I don't know why this video is not playing. So I might need to skip over it. Yes, unfortunately it is not, but quickly I can still use the screenshot to explain you. Let me just give it a final try. Okay, I apologize for this. I really don't know what's going wrong over here, but let me use this screenshot itself to explain you. So if you can see over here, this is the model. As you can see, this has some sort of logic in it. Basically, it's a cruise control logic that you can see over here. And over here on the bottom side, if you see, is basically the requirements. I'll try to zoom onto this. Yes, I can zoom onto this. And if you see, there are requirements written on the bottom side over here. Now, if I want to link any of these requirements to any of the pieces in my model, all I would have to do is just drag and drop this onto any of the pieces in the model. It's as easy as that. So I would just select this. For example, in this case, engage cruise control is selected. I would just drag and drop this, for example, on an OR, and the requirement would be linked with the design or the model that I'm developing. At the same time, once the requirement has been linked with a particular element in the model, you would see that it will have these banners or these gray icons that are appearing on the blocks. So for example, on this AND block, if you see, there is a banner or a gray icon that is appearing. And if you would just click on this gray icon or the banner, it will show you what particular requirement is being implemented by this AND block. So in this case, this AND block implements engage cruise control requirement. And if I just zoom out again, if you want further details about the requirement and what are the finer details of this requirement, on the right hand side, which is slightly cut out in the screenshot, sorry about that again, you would see the description of the requirement in detail. So that would be also there. And finally, the moment you start linking the requirements back with the model, you would start seeing the status of the implementation bar changing. So if a particular requirement is not linked with the model, it would show a blank status, meaning that no requirement or no model element is linked with this requirement. And on the other side also, it shows the verification link. Basically, it shows that how many requirements or whether a particular requirement is linked to a test case or not. Okay, so for example, in this case, engage cruise control is a requirement which is not linked with a test case. Okay, so and in cases where the requirements are linked with the test cases, if the test cases are not executed, you will get a yellow kind of a display But in cases where the test cases have been executed on the model, and if they have passed, it will show a green. If they have failed, it will show it in the red. So in this case, if you see the sum total, it is showing that, okay, few test cases have passed and few test cases have failed and few test cases have still not been executed. And on the bottom over here, you would also see the links appearing for all the requirements. So this is how basically requirement perspective or requirement linking and traceability process works. Let me just see if I can go ahead. Yes. So like I said, you can link the test cases back with the requirements, as I showed you earlier also, and you get different verification statuses right here in the progress window or the progress bar, whatever you might want to call it. And again, they have, each color has its own notation: pass, fail, unexecuted, and missing. Furthermore, when you see that, okay, that there is a requirement is missing a link with the test case, recently, starting with 2020A, we came up with something called as a traceability matrix, which gives us a matrix kind of a view where I can, again, this video, I don't know, all my videos are not working. So it gives me a matrix kind of a view where I can populate all my test cases against all the requirements, or all my model elements against the requirements, and see which pieces are linked or not. So it's like a X and a Y kind of a matrix. And I can see what pieces of the requirements are linked with the test case, or what pieces of the requirements are linked with the model or not. And if there are any missing pieces, I can directly from the traceability matrix itself establish the link. So for example, in this case, the break requirement is not linked to a break test case. What I can easily do is that just double click on this and link it with the test case that I have already authored. So this is again a very useful view, because as and when our projects and models start getting complex, it sort of becomes hard to manage all these traceabilities in a single place. So this traceability matrix would give you that flexibility where you can visualize all the links established between the model, the requirements, and the test cases. Okay, and if you see any missing gaps from the traceability matrix, you can close those gaps, or you can review those gaps and analyze why are those gaps present in the first place. Okay, let me just move forward with this. So now we have seen how you can work with the requirements, the model, and the test cases. Now let's quickly look at how you can author the test cases. So let's look at the first portion. If you are on to model-based design, essentially, and using something called as Simulink test, you should be able to create an automated functional testing framework that is very well integrated with all the tools that are there inside a model-based environment that will help you in doing verification and validation of your models. So this will basically help you in running the test cases, finding out what all test cases are passing, whether they are failing, what is the coverage that you are getting based on these test cases. And finally, when you are working on large projects and large software systems, you can also execute all these test cases created via Simulink test on Jenkins kind of continuous integration platforms. Okay, so all the test cases can be automatically be executed on the Jenkins or the CI platforms that are there. So let's look at how this automated framework can be used or can be executed on the model. So let's say you had certain functional requirements out of which you created a model. This model can be created in Simulink, Stateflow, or it can be even an architecture model linked with further with an implementation model. So any three of those things can work. So let's say you have created this model. Now you want to test this. So via Simulink test, you can first create a harness environment for this particular model. So basically, harness is basically an isolated environment that will help you in testing the model or the design that you have just created without altering your actual design in any way. So you wouldn't have to change your actual implementation or design, but you would have an alternate or an isolated environment where you can do the testing of the model or the design that you have just created as a standalone. Okay. So this is what we call as a test harness environment. Once you have created this test harness environment, the next obvious step is to create the test cases. Again, there are various methods like using an Excel, using a signal editor block inside Simulink, and even using a Simulink test sequence block inside Simulink test to create your inputs. And also at the assessment side of things or at the output side of things, you can again use an Excel test assessments and unit test frameworks to validate the outputs. So this is how you can easily create an automated environment for testing your models that or the designs that you have created from your functional requirements. But like I said, the process doesn't stop over here. And again, from an ISO perspective, everything needs to be linked back with the requirements. Again, all these test cases that you're developing inside Simulink test can be linked with the functional requirements using which you had developed the design. Okay. Now, once you have done this, when you execute all of this together, you would be also able to collect the model coverages. So if I just go ahead, once you have created all, like I said, once you have created all the test cases inside Simulink test, the next obvious step is basically to execute these test cases on the model. And at the end of this execution, you would be able to collect or measure the coverages of these test cases back on the model. And this would help you in identifying, okay, what are the missing portions in your model that are not yet tested. And again, this can be easily seen, as you can see in the snaps that I have in this slide, that the blocks of the model are highlighted, showing which blocks have been covered and which blocks are not covered. So if you see this green, which is a unit delay block, it is completely in green. It means that it has been fully covered. And there are blocks in red, which means that there is some amount of coverage that is missing on these blocks. Again, in the actual tool, if you hover over these blocks, it will tell you, okay, what is the missing piece. And also at the end of the day, the most important thing would be to generate coverage reports, and that can again be easily done just by a button click. You would be able to generate coverage reports that can again be submitted to the auditors for your ISO 26262 process. Moving forward, there is a strong need, especially when people are doing coverage-based testing, to prove that the coverage that is obtained on the model from a particular test case or the coverage obtained from the model is belonging to a particular test case and is just not unrelated coverage. It is not random coverage that you have obtained, but there was actually a functional or a requirement-based test case that helped you in covering that piece of block in the model or piece of logic in the model. And this is again a very necessary requirement from an aerospace or a DO 178C kind of a development platform or a standard, and is also now widely used in ISO also. So what is happening over here? Starting again from 2020A or version 2020A, we can tell you that the requirement or the coverage that you have obtained on a particular piece of the model, whether it came from a test case that was linked with a requirement or whether it came from a test case that was not linked. Okay. So whether the coverage that you got was a related coverage or it was an intended coverage, or it was simply a coverage that was, I won't say by fluke, but it was unrelated. So that particular block was never, or that particular logic was never intended to be covered by a particular test case, yet some test case was able to cover it. And so that's just, I would say that's by fluke, or somehow how that's how your system is, but that is not called as a requirement based coverage. So in that case, we would be able to tell you that, okay, that a particular portion of coverage that you have obtained was from an unrelated test case. Okay, so again, in this case, you would have to go back and see whether you need to modify your system or whether you need to modify your test case in order to get better coverage for that particular piece of logic. Moving forward, so now we have done the testing, the management of the requirements, and we have measured the coverage. Another thing that can be performed on the model itself is making sure that the models that we are developing, they follow certain guidelines, standards, and practices. And for the same, we provide something called as Model Advisor via Simulink Check that helps you in running all these standard guidelines and checks on the model, so that you can say that the model that you have developed is following certain best practices of the industry. And what are these standard checks that mostly organization follows? So here is a list of built-in checks that a lot of customers follow. And these are some of the checks that we also provide as part of the shipping product. So these are DO178 checks, ISO 26262 checks, MISRA C12 checks, CERT-C, and a lot of other checks that are there. The most popular ones, especially from an automotive perspective, are ISO 26262, MISRA, and MAB checks. So MAB is again MathWorks Advisory Board checks that are given to us as these checks are basically are a part of our long-term collaboration with the customers, and they have given us back some of the best practices which we have put back in the form of checks. And you can again execute these checks back on the model to say that, okay, that your models are basically following the best standards and practices of model-based design. Okay, and for those of you who are working with Japanese customers, you might have already heard of it, but if not, then for Japanese customers, JMAP would be one of the standard guidelines or rules that they would be interested when they are using model-based design for development of softwares. Okay, moving from here, you can also do something called as edit time checking, where during the development, again, there was a video over here which is not working. Edit time checking is that when you're developing the model, at the time of developing or while you're developing the model, if there are any violations in the best practices of developing the model, it will tell you then and there itself. So you don't have to really wait to finish off the model and then run the check. Instead, in this case, you would be as and when you are developing the model, some of these checks, if they are failing, they will be flagged then and there. So you don't necessarily have to wait till the end of the completion of your model. So with that, we come to the next step of checking the model. Again, from a design or a robustness point of view, is where you can use a very advanced mathematical checking way, which is called as formal methods, to make sure that your design is free from certain errors like integer overflow, dead logic, division by zero, array out of bounds, and so on. So using this, you can find out, okay, whether your design is robust enough or not, and whether it has some of these flaws in it. And if it finds out that there are certain errors like integer overflows, dead logic, and so on, it will also generate and counter example for you so that you can reproduce and see the error by yourself. So a lot of times when I'm working with customers, they say that, okay, we see that there is a division by zero possibility coming in the model, but we don't have a test case to, again, create that division by zero possibility. So in that case, people can use something called a Simulink Design Verifier, which will help in identifying, again, this division by zero. And it will, at the same time, give you a counter example because the models are huge. So it will produce a counter test case or a counter example using which you can again run that test case on the model and see for yourself how that division by zero might occur in your model. And this is valid for most of the errors that are there or that can be checked by Simulink Design Verifier. Okay, finally, we come to the last piece of model verification and model checking. That is basically making sure that your design always and always meets the requirements. Okay, and this is where we run something called as a methodology called as property proving, or where we try to prove that the model behavior is always in line with your requirements. And this is very well relevant for some of the safety critical testing that you might be doing in your applications. So how is it and what it is? So let's assume a scenario. So I have a safety requirement which says that when the brake is applied for 3 consecutive steps, the throttle shall go to 0. So that's an absolute safety critical requirement. And now I need to make sure that the design that I'm creating in whatsoever scenario would never deviate from this safety requirement. Okay, so how do I realize this particular scenario in my system? So in this case, what I would do is that, as you can see on the top piece, which is again a cruise control logic, is my actual design. And below is the safety property. And what is that safety property? It's the requirement. It's this requirement in the form of a model. So if I just go forward, so the safety property is basically, again, so the brake 3 consecutive steps should not reach certain value. Okay, so this is my safety requirement, which will be executed along with the model that you have just developed or along with the design that you have just developed. And then the tool will make its case that it will try to make sure to find out cases where your design would violate this property that was defined as a safety critical property. And once it finds out that that your design or your model has a chance of violating this property or this particular safety requirement, it will give you a counter example using which you can reproduce the same behavior on your actual model and see for yourself what is going wrong in your design model. So this is a very, very robust kind of testing that can be performed. We typically recommend it to be done on safety critical properties because doing it on all the properties might not be possible from a time and the effort point of view. But if it can perform from a safety point of view, it will add a lot of value to the software that we are trying to develop. Okay, so moving forward from here, till now, what we have seen the model that could have been used for code generation. We have tested it completely. We have now, we are now fully satisfied. We have gained enough confidence in the model, and we have produced all the artifacts from the testing of this model. And now we can proceed towards the auto code piece. So we can go on and generate the code. And once we have generated the code out of this model, we come to the next phase of verification, which is basically the code verification of the generated code. And this, as you can see, again, basically comprises of a few of the things that we have already done. One is making sure that the code and the model and the requirements, they are all traceable to each other. Making sure that your entire code is coverable. So in the sense that you should have 100% code coverage, making sure that the code and the model behave in the same way. So doing something called as back-to-back testing. And again, making sure that your coverage, you have tested the models fully. So let's see quickly how this can be done. So the most important piece in the entire code verification process from a model-based perspective is making sure that the generated code is working as same as your model. So how will we do that? In this case, as you can see, you would have started with the model. You would have executed certain test cases on the model, which we call as MIL in model-based environment. Once you have executed this, you would have results. Now you would generate the code out of your model. And once you have generated the code, you can compile the generated code on your host and basically run the same test vectors on the compiled code, okay, for on the host, and compare the results of the model and the code. Okay, so once if the results of both of them are same, then you can essentially say the model to code conversion process is perfectly, and it does not have any errors in it from a functional point of view. So, like I said, this basically shows that that there is an equivalence between model and the code. You get to know how much execution time your code is taking, and also you are able to collect the code coverage at the end of this process. The same process. Is there a question? Okay, I think I'll continue. Okay, so at the end of this process, you would be also able to collect code coverage. And the same process can also be repeated on your target hardware, where I can again generate the code, but in this case, I can cross-compile the generated code and flash it as a standalone onto my hardware or the target hardware, and again run the same test cases that are executed on the model, but this time on the code that is running on the target, and again compare the results between the both. So this will give me added confidence saying that even after post cross compilation, also my code even on the target gives the same results. So that's another step that I can go and do. Okay, now at the end of this, again, you can collect all the coverage and all the artifacts and the reports, and henceforth you can prove that the model and the code are working perfectly in line with each other. Again, there are other steps that can be taken, like doing a HIL or a hardware in loop simulation if that is required for your process. It can be again automated using Simulink test as a framework for testing the models. Okay, so this is just, I wanted to show a quick snapshot how easy it is to set up. So if you see, the top model is in model in loop environment. So you have the inputs which are coming from a signal builder block. Then you have a model logic, and then you have outputs in the form of a scope. Again, it's just by a drag and drop of a button or changing of a switch, you can say in the sense. You can execute the generated code. As you can see, this will execute in software in loop mode. And again, if you have the hardware connectivity established with MATLAB and Simulink, again, by drop down, you can select PIL mode and execute the same vectors on the model. So it's as easy as that. Okay, so like I said earlier, at the end of all this testing, you would be able to get the coverages. And again, these coverages can be submitted to the auditors for collecting the relevant credits for doing the code coverage also. Okay, so with this, we come to the last piece of the verification of the code, which is doing the runtime error detection of the generated code and also the Messer analysis. Though in this case, we are talking about the generated code, but most of these strategies are very well relevant for even the hand code. So if you are typically working in just a hand code based environment, you can use the same tools, you can use the same set of strategies to perform Messer analysis and runtime error detection. And this is primarily done by using something called as Polyspace Bug Finder. So if you're working at a component or at a unit level, or basically at a developer level, then you would be basically running something called as Bug Finder or Polyspace Bug Finder to do static analysis. And this static analysis would basically help you making sure that the code that you have developed, whether it be generated code or whether it was hand code that the developer has written, is basically high quality and it is secure, and it follows guidelines like MISRA and all. Okay, and it also gives you code complexity numbers if that is of importance to you, which in most of the cases is. So you can also collect those metrics out of running the bug finder. But if you are wanting to run static code analysis on a larger code base or on a bigger piece of software, then we would suggest you to use CodeProver, which not only would verify or tell you that okay how good your software is, but it will also tell how robust is your entire software that you have created. Basically, it will tell you whether your software is free from critical runtime defects or vulnerabilities, and also will produce artifacts for that basically that can be produced for getting the credits for your certification. So for your MISRAs and for the CertCs and all, you can get the relevant artifacts created, again, which can be submitted to the relevant authorities to prove that, okay, that you have followed certain guidelines while creating the code. Okay, so this brings me to the last part. So we are done with the entire model-based development process. So with this, we finish off, and now the code that you have developed is ready basically to be used. And what is after this? So basically in this entire workflow that I just talked about, you would have used a lot of products in the process. So for all of these products, from an ISO perspective, you would be required to go through something called as a tool qualification process. And to support you in this tool qualification process, we provide you something called as a tool qualification kit, which has these different artifacts, as you can see. So this has the tool use case document, workflow conformance document, validation reports, tool classification reports, and all. Using these artifacts, you can basically get the tools that you have used in this model-based design process qualified, and basically by producing the final report and get the relevant tool qualification credits for it. So if I quickly go ahead with the typical tool qualification process, typically in the tool qualification process, you would first start with the tool classification aspect, where you would define the tool's use cases. And based on the tool's use cases, you would define the tool impact analysis. So this impact would be basically whether the tool can introduce errors or fail to identify any defects in itself, okay, or fail to identify any defects. So this would basically comprise your tool impact. Based on the level of tool impact that you would have seen, you would say that, okay, you would define a tool error detection level. Basically, if there is a chance of an error to be introduced by the tool, can we know it before, or can we prevent it? Okay, so that would basically classify, on the basis of that, you would classify your tool error detection level. Again, it can be 3 levels. If you are on TD1, it will lead to tool confidence level, and that would require no further qualification of the tool. But if you end up in TD2 or TD3, which will basically be TCL2 and TCL3 levels of tool confidence, then you would require some amount of tool qualification to be done based on the ASIL levels of the product that you're developing. So if you are following, or if I can go ahead and say, if you're following an ISO process, again, typically for TCL2 and a TCL3 level, you need to follow just one of the qualification, or at least one of the qualification methods as specified by this table. So this is, I don't exactly remember the table number, but there's a table which tells, okay, based on the TCL level, what is the qualification method to be used. So you need to use at least one of the methods. And in this case, for model-based perspective, and based on the assessment tool cert kit that we provide you, we have already made steps B and C very much available to you by the help of the tool cert kit that we provide, or the tool qual kit that we provide. So evaluation of the tool development process and validation of the software tool can be easily done using the cert kit provided for the tools that is there that I just talked about earlier. Going ahead, like I said earlier at the very start, most of the tools that are used in the ISO 26262 process, they have been pre-certified by TUFSID for ISO development process. And here is an example of one of the tools which sort of is most critical tool in the entire process. You can say, which is Embedded Coder, which is Mathworks code generation solution. It has been qualified for TCL1 level, or certified at TCL1 level. If a particular workflow is followed, so there is a reference workflow that Mathworks suggests. If you follow that reference workflow in its entirety, then Embedded Coder can be put under TCL1 level, and you can practically go through without any further qualification required for Embedded Coder. But if you are having certain deviations from that process, then from that reference process, but still you're following more or less at a high level that entire reference workflow, then also Embedded Coder would stand at TCL2 or at TCL1 level. And in that case also, we provide you with the relevant artifacts so that you can qualify the tool for your certification process easily. Okay, so this is in general that I just wanted to discuss. And if I could summarize the entire workflow, this is an entire workflow. I know it kind of looks overwhelming at first, but this is in its entirety the entire ISO 26262 reference workflow, and all the tools that can be used at various stages or at various steps based on the ISO's requirement. And this is the reference workflow that we have also got certified by TUFSID to be used for ISO development. Okay, so there are other customer references and applications that are available on our website. So if you are interested in knowing more about these products or how some of other customers are using these, please go through our web pages. You'll find tons and tons of information over there, how some of our customers are using these tools. Since anyways, I'll be sharing these slides and you will be getting access to the slides. I've already put the relevant web page link, so you can go and see through this web page link how the customers are using these tools. Finally, if I could summarize, Mathworks provides a pretty comprehensive support for ISO 26262 software development. And as you can see, there are different ways of how you can work with us, and there are a lot of information available. One of the ways how a lot of our customers work with us, especially on ISO 26262 projects, is via consulting. So if you are interested in going through an entire project for ISO 26262 and you want a full-fledged model-based design process set up for you, then you should reach out to us and we should help you in that setup by working with you in a collaborative manner. And to get more details, I have put some of the links over here. As you can see, there's a link over here to our ISO page. So once you get these slides, please, I would recommend you to go through some of the information that is available on this page. It will give you an idea about the reference workflows and the tool qualification part and the various tools in general that are used for ISO 26262 process, and how are some of the other customers using the tools. Finally, below is our mail IDs that are there. So if you want more information, feel free to write back to us. The first one is Prashant's mail ID. Second one is my mail ID. Feel free to write back to us in case you want more information and if you want some more details about any of these products, or if you want to basically start using some of these things back into your workflows. So we would be very happy to work with you and help you with this regard. Okay, So with that, I come to the end. Thanks for your time. I think I might have gone 10-15 minutes overboard than what I had promised, Suraj, but that's fine. Uh, I hope you found the session useful. We are still there, so I'm open to taking the questions. So yeah, just yeah, feel free to ask me questions if you have any. Yes. And I,
Hi, Rajat. Actually, Suraj here. We have a question in the chat box.
okay, okay,
Mr. Satyendra.
okay,
It says slide number 16.
okay.
How to track the impact if a requirement is changed? Will it throw some notification?
Yeah. So okay, let me just pull up. So if I can start sharing again. Mm. Yes. So unfortunately, I don't have the right slide, and neither is my video working. Let me. Which was the slide, Suraj, that you mentioned?
It was slide number 16. Yeah.
16 or 17. Yeah. Yeah. So yes, the impact of a change is so the if there was a requirement changed, typically, as you can see, the requirements. If you see the requirements here, the background is right now white. Okay, if there is change either in the linkage or in the requirement, okay, then the background will turn into a lightish pink color, so that would indicate, okay, there is something that has changed. So now it's up to you that you check what is that change that has happened in the requirement, whether it was the requirement that got changed or whether it was the model that got changed and you haven't really reflected it back onto your actual requirements. Okay, so yeah, that's how it will show you the change. Okay.
Uh, so any participants, do you have any questions? Please unmute yourself and you can ask the question directly to the speaker.
Rajat, this is Nagraj here.
Yeah, yeah.
You shown some design, right? Is these designs are standard design or uh, like it is customized? It may be
You
customized.
Yes. So okay, these are some of the I guess you might be talking about this one that I might have shown. Uh,
Correct, correct.
Yeah, so the thing is like this, we typically we don't give any designs as such, but we give you what is called as reference applications. Okay. So for example, if you're developing, in this case, like it's a cruise control, so we would have a small reference cruise control application kind of, which you can see and get an idea, okay, how you have to model and all. But at the end of the day, yes, you can fully create from scratch. Okay. You can create your own design, or even if you want, if you feel that okay, the design that we have as part of the product suits your need and it requires any tweaks, please feel free, you can tweak them. It's all up to you. Yes.
Mm.
Okay, so but full flexibility is there for you to start from scratch, or if you want some of the reference that are there, if they are useful for you, please use them. Yeah, no problems.
Yeah, clear, Rajat. Thank you.
Okay, let me see in the chat window. Okay, so any other questions?
Yeah, one question here. So you
Yeah.
said that the change in the requirement can be
Yes.
seen, yeah, in
Yeah.
the color change.
Yes.
Does it, I mean, can we choose which field can be actually selected? Basically, if it's the text or the object itself, or let's say sometimes we also have the validity, right? Whether the requirement has gone obsolete, for example. So can we have a choice also? With respect to that?
No, I don't think so. We have a choice. I would need to check that. I'm not very sure about that. I
Okay.
would need to check that. It's a request to you. Could you please shoot down a mail to me with that query? It will be very helpful.
Yeah, sure.
I can respond directly back to you on that. Yeah.
Okay. Yeah.
Yeah.
Thank you.
Thanks a lot. Yeah. Okay.
So any more questions? Please do unmute yourselves and you can ask the questions to the speakers directly.
Okay. So once if we have a couple of minutes, what I can also share is one more thing, which I thought might be useful. Let me just see if I can pull it up. Just give me a second. Mm, it should be here. Yeah. Meanwhile, if you have questions, feel free to jump in with the questions.
So, participants, if you have any more questions, please do ask. If not, we can wind up the session in another 5 minutes.
Yeah, Rajat, is it possible to show your tool like just a simulation methods or some uh, like
Okay.
you
Let
tell
me.
me?
Mhm. Yeah. Let me see if I
Yeah,
can
like
fire it up quickly. Yeah. So I've just started it up. Uh, So, meanwhile, it'll take a few minutes to open up. Meanwhile, it is opening up. It might take more minutes to set up because my PC is kind of very slow. Uh, but what I would also recommend you in that case, and I was opening this document itself. So this is the web page that I was talking about, which is over here. And if you refer to this web page, it has got a lot of information about, especially on ISO 26262 part of MATLAB and Simulink support on that. And there are a lot of videos also available. So there are videos, there are customer references. So for example, this was the coastal story that I was talking about, the LG story, the LG Kim reference that I was talking about from the start, that is there. And then there are some webinars also available. And there are a lot of videos, sorry, that is also available that you can also refer to. So just in case if, yeah, so my tool will take some time to set up. But just in case, if you want to look into depths of how things work actually inside model-based design, I would say head over to our webpage. It's as simple as mathworks.com. And what I would say is that go to solutions page, go to ISO 26262, and there you'll find all this information. Along with that, you can also go to something, you can just simply, I would say, search for videos, and there are a lot of videos available so that you can see how the product works. Okay, now let me see if it is coming up. Yeah, I have a super slow kind of startup with the tool. It's because of my PC in the last moments staying its last breath, I would say. So yeah, unfortunately, it will take some time. Okay. Yeah. Any other questions? Meanwhile, this thing starts up.
yeah, just I wanted to know like in code
Uh-huh.
generation, is it
Okay.
supporting this popular compiler options and everything? Like if
Mhm.
you are using GSS compiler, like is there like how to select it and generate a code so
Okay.
that will get
Yeah.
object?
So yeah. So that's a very good question. Now, the thing is, typically, when we are talking about code generation, uh, we typically tend to keep the code generation very, you can say, hardware independent. Okay, so everything that we are generating is basically um, mm, is basically hardware independent, and it is free from any hardware dependencies as such. Okay, hardware or any compiler dependencies as such, because the code that we're generating is purely ANSI C code. So if in case you want certain compiler dependencies to be brought inside, can be related to any of the compilers that you might want, we might need to make special provisions in it. But typically we usually would not recommend you to do that. But yes, if you still insist on, and then we can make certain provisions if possible, or if they are feasible in the first place, and bring them into the code. Okay. By the way, may I know what things that we are looking at when you say GHS?
Yeah, that's what like yeah, basically like we have like safety monitoring, right? Like we'll be having some safety mechanism and which will be fulfilled by some safety monitorings. Uh,
Okay.
we'll be writing some logic for that. So
Okay.
I guess that can be yeah done in the Simulink by making this model coding and everything, and then we can generate a code. Uh,
So.
but
Mhm.
yeah, as we know, like this, yeah, many of this, this is the like kind of BSW code, and it is going to sit in the microcontroller, and we'll be
Mhm.
having yeah, hardware dependency, and we need a specific compiler
Yes.
like GSS and everything.
Yes.
So just I wanted to know like how it can be, this tool is supporting, and if it is supporting, how it will be done in this tool settings and everything.
Yes. Yeah. So I don't know if you mean by the monitoring code, do you mean things like double safety storage and all those kinds of things?
Yeah, correct, correct.
Okay. Yeah. So those things, there are, it's not a standard thing that can be done with the off-the-shelf product, but we can employ modeling techniques to basically enable that and to make that happen. Okay, and then get the relevant code generated. I know that's kind of an important need, the double storage setting. Yeah, so we can make provisions for that. Okay, but yeah, typically again, if I just go back, and since you mentioned BSW and talking about AUTOSAR in general, we typically would target the application or the software component piece of AUTOSAR, or in general, the automotive ECU. Okay, yeah. Okay, so here is the environment. So it is up and running now. So let me see if I can quickly open an example. So let me just go to talk. And yeah, if I go to code generation, for example, I can go to embedded coder, I can go to examples. Let me see if I can open. Okay, let's take this one. This one might be the simplest, yeah. Again, this might, yeah, it's starting up. It might take a few minutes to come up. Yeah. Meanwhile, if there are any other questions, again, I don't know. It's super slow with my PC. So yeah. Any other questions? Feel free. Yeah, I don't know. Okay, there it comes up. So yeah, this is the model. Right. kind of I think. Yeah, and you can basically, this is a sample example that like I was showing, this is a sample example that is there. And yeah, if you want, you can simulate this by clicking on the button. Right now, I think the simulation has disabled for this model. So I cannot simulate it right now because it was setting up. Now I think it is enabled. So I can simulate it. Yeah, but this is the logic that you can develop, and if you want, you can generate code out of it. You can simply traverse to the code generator, which is embedded coder in case of MATLAB. And if you go to embedded coder, you can basically start the code generation process for generation of code. And yeah, like I was saying, you can either use the entire logic as is if you want, but in most of the cases, I can say almost 99.9% of the cases, people would develop their own logics and own modeling styles from scratch. Okay, so yeah, hope this helps.
Yeah, thank you.
Any other questions or any final questions that we can take? I don't know if there are any questions in the chat window. No, I think there are no questions. I think we will be sharing these slides for sure. Yes.
Yeah, I think there aren't any more questions. So thank you so much, Rajat, for giving your time for us and valuable and knowledgeable session today. So once again, it's in hearty thanks from SA India and team here. So thank you and have a good evening. Good night.
Thank you, everyone. Thanks for your time. It was really great interacting with you all. Good evening. Good night. Thank you all. Bye.
Yo.